Hello, good morning, everybody. Happy Thursday. Welcome to another episode of Math with Mr. Taco. Here we are. Useful fraction to decimal conversions. We're going to take all that kind of decimal knowledge that we've been working on over the last weeks and months, really, as we started thinking about just decimals as a concept, as an extension of place value, and then we got into multiplying decimals, and now we're here in dividing decimals. Fractions and decimals do appear pretty regularly out in the real world. There is lots of math out in the real world. And it's helpful to spend the most time on the stuff that's the most useful out in the real world, right? Particularly decimals, because we see decimals all the time when we're dealing with money, right? Our money system works on that same base 10 system, right? With tenths and hundredths and so on and so forth. And so when we're out there and dealing with money, we really want to be comfortable with, okay, what's half of a dollar? What's a third of a dollar? What's a quarter of a dollar, right? What's a fifth? What's a tenth, right? The other thing is, you're going to continue to see fractions and decimals and have to work with fractions and decimals as you progress through math in school. So knowing and being automatic with some of these fraction to decimal conversions is going to be really, really helpful. Down here, there's the I cans. I can divide a dividend into equal groups using the standard algorithm. I can use place value knowledge and solve unknowns with decimal dividends or decimal quotients. We're going to be doing some of that today and putting some of that fraction to decimal conversion work into practice. But first, let's kind of go over some of the common, let me straighten out my thing there we go. Let's start by kind of going over some of the more common fraction and decimal conversions things you're going to see out in the world. Okay, we're going to talk about halves today. We're going to talk about thirds. We're going to talk about fourths. We're going to talk about fifths, and we're going to talk about not sixth. I bet you thought I was going to say sixths. No, we're going to talk about tenths. Halves, thirds, fourths, fifths, and tenths. Okay, these fractions, I think, as an adult, as an old ancient person, okay, I think these are the fractions that I see most often in the real world, right? Here's your dimes, a tenth of a dollar, right? Here's your quarters, a quarter of a dollar, right? Often, you're going to a restaurant, you're splitting a meal in thirds, right? Dividing up who pays what into three groups, right? You're going to need it. So thinking about a third as we go. All right, we're going to start down here at the bottom with tenths. Why? Because tenths are the most simple fraction to decimal conversion, because we have a tenths place in our place value system, right? 1/10 equals 0 and 1/10. Ta-da! Easy peasy lemon squeezy, right? Just like when thinking about, essentially what we're doing here is we're taking one thing, we're dividing it into 10 pieces, into 10 groups. How much is in each group? It's a tenth, right? Just like our shortcut of take your decimal point and move it over one place to the left, essentially shifting everything one place to the right in order to divide it by 10. Okay, so there's our shortcut, right? If you have something like, $38.72, right? And you want to know what's 10% of that, what is 1/10 of that, all you got to do is take that decimal point, move it over one, and look here, right? $3.87 is 1/10 of $38.72, okay? Tip more than 10% though, okay? And then from there, now that you know 1/10, you can calculate multiple tenths, right? If I want to know 3/10, all I got to do is I got to take this amount, multiply it by 3, right? In the real world too, you might even round up and multiply it by 3 if you wanted to find about 30%, right? Round this up to what's the nearest whole number? $4 times 3. So 30% or 3/10 of, our $38.72 is going to be about $12, right? I do this a lot when I'm like at a store, for instance, and I see the price. I'm looking in the sale rack because look at me. I shop at the sale. I shop on the sale rack. Okay, and I see a shirt that, you know, maybe it's $42. Okay, and it's got a tag on it that says 40% off. Okay, I want to know. Okay, if I'm taking 40% off, I want to take 4/10 of the price and subtract it. So I need to know 10% or 1/10. So I'm going to go, okay, $4.20 times 4. $4 times 4 is 16. 20 cents times 4 is 80 cents, so $16.80. Subtract that from the price, it's about $27 left. That's a pretty good deal on a shirt. I might go buy it, right? That's the kind of math that we're doing out in the real world, and it helps us, you know, when we're buying clothes, we're buying food, we're buying, bigger things like, heck, 40% off a TV, right? 40% off a, 40% off an airplane ticket, 40% off a season pass to somewhere, right? We want to know, especially with money, we want to know and be really exact about how much we're spending and how much we're not spending and how much we're saving, right? Because it makes a big difference. So being able to do those conversions is pretty important, okay? Fifths, similarly, right? If we're doing, essentially what we're doing when we're saying 1/5 is we're saying 1 divided by 5, right? I can't do 1 divided by 5, so I got to regroup it with some tenths. And then I have 10/10 divided by 5. What's 10 divided by 5? 2. So we know that 1/5 is equivalent to 0.2. Okay? Or 1/5 of 100 is 20%, right? So 20% is just a fifth of what your whole thing is if you're dealing with money, okay? This can be particularly important if, let's say, I have a problem like, 231 divided by 5, right? 23 divided by 5 is 4 with 3 left over. 31 divided by 5 is 6 with 1 left over. Now I know, I'm doing this shorthand, sorry. But now I know I have 1 out of 5 left. I have 1 remainder divided by 5. So I actually don't even need to do this last step. I can just throw a 2/10 on there, right? Because I know that 1/5 equals 2/10. Okay? Makes calculating your remainders go a lot quicker. Likewise, we can add these, right? If 1/5 equals 2/10, 2/5, or 1 plus 1/5 would be equal 2/10 plus 2/10, or 4/10, right? I'm checking the chat here before we jump ahead. Okay, yeah, it was just that bit that I was writing while it was off the screen. Now, 1/4, right? 1/4, a quarter. Okay, in our place value system, right, we think about how much is a quarter of a dollar, right? How many cents is a quarter? It's 25 cents, right? And cents, like century, we call it a cent because it's 1/100th of a dollar, right? A century is 100 years. Centennial means 100-year anniversary, okay? So if you see cent, usually that means, cute. Sorry, I got distracted. There's a mockingbird that's right outside the window, and it's looking in. Anyway, 1/4 equals 25 hundredths. Okay, we can prove that. We're going to take 1, we're going to divide it by 4. Okay, we can't divide yet, so we're going to put a 0 there. Regroup this into 10/10. Divide that by 4. How many groups of 4 can I make with 10? Well, I know that 8 divided by 4 is 2. Subtract, we're left with 2/10. We still have something here, so we've got to keep going. We're going to add another 0 in the hundredths place. Now we have 20 hundredths divided by 4. And 20 divided by 4 is 5. Okay, so there's our proof there. 1/4, 25 hundredths, or 25 cents if you're dealing with money. Okay, we're going to skip up to 1/2. We're going to skip up to 1/2. Okay, because again, right, we can prove this one. 1 divided by 2, which we can't do right away. So we're going to add a tenths place to regroup it. And what is 10 tenths divided by 2? 10 divided by 2, or 2 times what is 10? 5. Okay, so our 1/2 equals 5 tenths, right? Half of a dollar is 50 cents. 50 hundredths, right? Equivalent to 5 tenths. We don't need the 0 there. When we're dealing with money, we do need the 0 there, because we always, when we're dealing with money, always put the tenths place and the hundredths place, just as a matter of organization and clarity. Okay? Now let's go to the thirds. I left the thirds till the end for a reason, because watch what happens here. Okay, we're going to take 1 and we're going to divide it by 3. Now, obviously, we can't do that right away. So, we can put a 0 here and a decimal point. Regroup to the tens. Now we have 10 divided by 3. Okay, look over here. Can we do 10 divided by 3? No, we can do 9 divided by 3. Okay, so let's do subtract 9 tenths. And then 3 tenths in each group. Okay, 10 minus 9 is 1/10. We've still got something left, so we'll add a hundreds place. Now we're doing 10 divided by 3. Let's check here. We can't do 10 divided by 3, but we can do 9 divided by 3. So let's go ahead and do 9 divided by 3. And 9 hundredths divided by 3 is 3 hundredths. Subtract 10 minus 9 is 1/100th. We've still got value here, so let's regroup and add a 0 in the thousands place. And now we've got 10 thousandths divided by 3. Oh no. We're just doing the same thing over and over again, aren't we? How is this ever going to end? Because we're going to keep the... Oh no. Oh no. We're still going. Oh no, we're still going. It's going to be 3's forever. Never fear. Okay. There is a mathematical trick, because this does happen. This is called a repeating decimal, or a repeating digit, where these 3's will go on forever and ever and ever and ever, infinitely. Right? So there's a couple ways you can show this. There's a mathematical way to show this, and what you do is you're going to take a line and you're going to put it over the top of that 3. Basically saying this pattern, whatever pattern is under the line, I looked up what this line, the name for this line was, and now I completely don't remember it because it was completely new to me when I looked it up. But this line above our digit shows that this digit, whatever's under the line, is going to repeat forever. Okay? If it was something like 3, 8, 4, 2, right? You put a line over the top of it. That's equivalent to 3, 8, 4, 2, 3, 8, 4, 2, 3, 8, 4, 2, right? And so on until the cows come home, okay? So whatever's under that line, that pattern is going to repeat infinitely. In this case, because it's 3's over and over again, we could write it like this and call it a day. Alternately, we can round. We can choose a place to round to, okay? Let's say the thousands place, and this one just stays as is, 3, 3, 3, 3, 3, 3, 3, 3, so on. Okay, it's going to round down to 3, 3, 3 instead of all these 3's, so on. Okay, So we could write it like this, any combination of 0.333. We could even, if we were writing it as an answer, we might put some ellipses afterwards just to kind of show that it goes on forever. Okay. Similarly with 2/3. If we have 2 divided by 3, we're going to get something similar. Okay. 0. 20 divided by 3 we can't do, but we can do 18 divided by 3. Which is 6. And then we subtract, and we're left with 2. Right? We add a 0 to regroup. We can only get to 18 in the hundredths place, which is 6, and so on. Okay? With this one, since it's 6666, and we're rounding, and this number is 5 or greater, we'd actually round up. And often your calculators will show this. If you do it on a calculator, it rounds up to 667. Okay? So 1/3 equals 0.3 repeating. 2/3 equals 0.6 repeating. Okay? Now let's look at some of these other ones just quickly. 1/4, 25 hundredths. 2/4, or 25 plus 25, right, is 50 hundredths. Or, oh, look at that. 1/2 and 2/4 are equivalent. I remember that. That makes sense, right? Add another 25 hundredths for 3/4. And so on, okay? And then same with the fifths and the tenths, right? 2/5, 4/10, 3/5, 6/10, 4/5, 8/10, right? Following that pattern of repeated addition. Let's try one division problem on our digital whiteboard. And I want us to think about what fraction to decimal conversion are we going to need here and is going to be useful here. So our problem is going to be 267 divided by 4. There we go. 267 divided by 4. Okay, so start with your largest place there, the 2. Can we divide 2 by 4 yet? No, we can't. We're going to put a 0 there so we remember, and then we're going to regroup. Okay, so 26 divided by 4. How close can we get? 4, 8, 12, 16, 20, 24, 28. No, 28's too many. 24 divided by 4 is what we can get to. And 24 divided by 4 is 6. Subtract. We end up with 2 10s left. We're going to regroup with our 7 to make 27 ones divided by 4. Okay, think about that one. Seems similar to the last one, right? It's pretty close. We can't get to 28, so we're going to use that 24 divided by 4 again, which is 6. And then when we subtract, we're left with 3. Now, before we go on and do and like add a tens place and add a hundredths place, tenths place and add a hundredths place, let's think about, we have 3 left and we're dividing by 4. 3 left and we're dividing by 4. What's our decimal equivalent, our decimal form of 3/4 here? Boom. 75 hundredths, right? So the more and more comfortable you get with it, you can actually skip the step of adding a 0, doing the tenths, blah, 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 because you know, okay, I'm dividing by 4, I've got 3 pieces left. That equals 75 hundredths. I can just plug that straight in there for a final quotient of 66 and 75 hundredths. Make sense? So I think the big thing with these commonly found fractions and their decimal equivalents is the more and more comfortable we get with them and the more and more automatic we get with them, they're no longer like mathematical calculations. They're now tools, right? As we develop automaticity with math facts, we can use them then as tools to kind of free up our brain space so that we can focus on the newer or the more challenging stuff, right? That's why it's a good idea to like practice your multiplication facts. Know in a snap that 6 times 8 is 48, right? So when 6 times 8 is part of a larger problem, you don't have to think and expend that brain energy, that calculating energy about what 6 times 8 equals, right? You can just know 6 times 8 equals 48. I'm going to use that as part of a larger thing, right? Seeing 26 divided by 4 in this problem and going, oh, well, 24 divided by 4 equals 6, right? And being able to snap to that, then that allows you to spend more of that calculating energy on the more complex stuff, okay? And getting automatic or memorizing, if you will, these smaller fraction decimal facts can be another tool in your mathematical tool belt, because you are mathematical superheroes with a mathematical tool belt who can use your mathematical facts to save the universe. Thank you, everybody, for tuning in. Office hour will be open promptly at 11 o'clock for the tacos that would like to ask questions or just want to drop in and say hi. And we will be back next week with more fun and fascinating mathematical content here on the YouTubes. Thanks for tuning in. We'll see you soon.